Okay, let's go over Chapter 6, Teleworker Services. This is a short chapter. You do not have any assignments on it. I did place a integrated packet tracer out there for you to attempt, but don't stress yourself out over it. Chapter 6 is Teleworker Services, and as you know, teleworking is a way of life now. There's many people who are able to work outside of the workplace. They can work at home or wherever they happen to be and still be considered working. Teleworking is a broad term referring to conducting work by connecting to a workplace from a remote location with the assistance of telecommunication. Efficient teleworking is possible because of broadband internet connections, virtual private networks or VPNs, and more advanced technologies including voice over IP, video conferencing. Teleworkers can save money otherwise spent on travel, infrastructure, and facility support. It just depends on who you work for as to their view on teleworking. Some people love the idea of not having to pay for space for their employees to work, and they're okay with them working from home. Some places would prefer that they have everybody in-house. Some of the business requirements for teleworker services: organizational benefits. We have continuity of operations, increased responsiveness, secure, reliable, and manageable access to information. It's cost-efficient integration of data, voice, video, and applications. Increased employee productivity, satisfaction, and retention. Some social benefits is increased employment opportunities for marginalized groups. That would be the groups who don't typically work well in a group setting, but they can do fine if they're on a computer and can work without the pressure of somebody being near them if they can't handle that. There's less travel and commuter-related stress. Some of the environmental benefits is it supposedly reduces the carbon footprints, both of the individual worker and the organization. Everybody's not having to travel so much. Some of the teleworker solutions: organizations need secure, reliable, and cost-effective networks to connect corporate headquarters, branch offices, and suppliers. With the growing number of teleworkers, enterprises have an increasing need for secure, reliable, and cost-effective ways to connect to people working in small offices or home offices and other remote locations with resources on corporate sites. You'll notice in this illustration you have your main headquarters. It may be a campus, may have data centers on it. You have your branch office. Here are your suppliers, and then you have your teleworkers. You can use IP secure VPNs, broadband network ISPs. You've got layer 2 VPNs, you've got frame relay, ATM, different devices there. Some of the teleworker connectivity requirements: you have your home office component, you have your corporate components, and then the optional corporate IP telephony components if your company is going to supply you with the phone system. And then you do everything over encrypted VPN tunnels. Connecting teleworkers to your WAN. There's different ways of doing that. There is dial-up. We all remember dial-up. With access speeds of 56 KB per second, dial-up access is the slowest connection option, and we all knew that. We have DSL, we have cable modem, and then you have satellite modems. Those are 4 of the different ways that you can connect. There's also fiber. You have a cable system, and if you read through this information on the website, it's got some just real good general information about what is a cable system, like Time Warner, that type thing. The cable uses part of RF electromagnetic frequencies. It can transmit signals simultaneously in either direction, and the RF portion used is subdivided for the two paths. You have downstream, which is head in to subscriber, has 810 megahertz of RF bandwidth, and the upstream, or the subscriber to head in, has 37. You have your doses, and it's the standard for certification of cable equipment, vendor devices, the cable modem, and the cable modem termination system. It specifies the physical and the MAC layers. It defines the RF interface requirements for a data over cable system. The cable equipment vendors must pass certifications conducted by Cable Labs. And then there's also the Euro version with a variation adapted for use in Europe. Data services run between cable modems and CMTSs, and users on a segment share upstream and downstream bandwidth. You have your DSL. It uses high transmission frequencies, technology for delivering the high bandwidth over regular copper lines and the connection between subscribers and COs. Some of the other DSL connections, you've got your small office, home office, you've got your provider network. Some of the maximum distance is 18,000 feet here. And then you have your provider, as I said. Here's the DSL router and DSL AMs. It's the different equipment that you would use. There's separate data for voice and ADSL connections. Here's your microfiber, how that would be set up. And then you have splitters. Broadband wireless, you probably have that set up in your home. There's municipal Wi-Fi, there's WiMAX, there's satellite internet. You could possibly have a single router, but the problem with that is if it goes out, no one's connected. Here's your mesh topology. You've got WiMAX and you have satellite. Your wireless standards and security. Your Teleworker equipment generally uses a 2.4 gigahertz range, complying with the standards of the 802.11b, G, and N. There is a packet tracer activity for you to do with broadband wireless. Again, I've only assigned the integrated for you to attempt. Read through here and understand what a VPN is. There's an analogy set up here so that you can see what it's like. And here are the benefits of the VPN: cost savings, security, and scalability. There's different types of VPNs. Here we have the POPs, we've got DSL, got the intranet. You can use the firewall to terminate a VPN. You can use a router, or you can use an ASA to terminate the VPNs. Some of the different VPN components. It creates a private network over a public network infrastructure while maintaining confidentiality and securing your VPNs. The diagram here shows a typical VPN topology. The key to a VPN effectiveness is your security. VPNs secure data by encapsulating or encrypting the data. Most VPNs can do both. Encapsulation is also referred to as tunneling because encapsulation transmits data transparently from network to network through a shared network infrastructure. Encryption codes data into different format using a secret key, and decryption decodes encrypted data into the original unencrypted format. Some characteristics of secure VPNs: the data confidentiality. It protects data from eavesdroppers. You have data integrity. It guarantees that no tampering or alterations occur. And then you have authentication, and it ensures that only authorized senders and devices enter the network. With VPN tunneling, you have your carrier protocol, and it's the protocol over which information is traveling. You have frame relay, ATM, MPLS. Encapsulating protocol, the protocol is wrapped around the original data. You got GRE, IPsec, L2F, PPTP, L2TP, and then you have your passenger protocol, the protocol over which the original data was being carried. Here's the encapsulation, an example of how that occurs. With your VPN data integrity, here we have encryption, then decryption. And when it's sent across the internet, since your hacker out here doesn't have the key, he can't exactly see what's going on. He would need the key to decrypt it. VPN encryption algorithms, symmetric algorithms, there's a secret key cryptography. Encryption and decryption use the same key. Typically used to encrypt the content of a message, and the examples are the DES and 3DES and AES. You can have asymmetric algorithms. There's a public cryptography. Encryption and decryption use different keys, typically used in digital certification and key management. An example of that is RSA. You have your IPsec security protocols. Make sure you understand what they are. Two of the main ones are authentication headers and encapsulating security payload. Go through and watch the scenario. Here's the central where you can go in and plug in what needs to be set where and understand how this works. You could always reset it and attempt it again. Here it is at the branch level. You would go in and do the same thing. Then you can reset it and try again. Again, a security. Here's central, and here's remote. Be sure you go through your chapter summary. You can do the little chapter summary here. It'll ask you questions. Here's a packet tracer integration challenge. And then the quiz, which will help you take the chapter test. Make sure you go through this before you take the chapter test. And good luck with this chapter.